Yeah. So I hope everyone understood what is decision tree, right? So whenever you apply decision tree algorithm, the data set will get divided into subsets. So how is this subset get divided? Until that becomes a pure set. So now you tell me, what do you understand by pure set? What do you understand by pure set? Can you please tell me what do you understand by pure set, guys? Guys, I'm telling you itself. Yes. So a subset is considered as a pure set if it is consisting of all positive values or all negative values. If suppose a subset is having all positive and negative values together, then you have to split the data set further. Split the data set further until that gets into a pure subset. So here I have a data set of 14 days in which I want to check whether the boy will play based on the weather parameters. So here we have weather parameters like outlook, humid and wind. Outlook, humid as well as wind. So first I would like to divide the data set on outlook. So can you please tell me how many observations are there for outlook? Sunny, rainy and overcast, right? Sunny, rainy and overcast. So whenever you divide this data, what happens? Whenever you divide the data, it becomes like this. Yes or no? Did you understand this? So in Outlook, I have three categories. I have three categories. One is overcast, rainy and sunny. So all the observations of overcast will come under overcast. All the observations of sunny will come under sunny. And all the observations of rain will come under rain. Fine. So here if you see, overcast has all the positive observations. So this is considered as a pure subset. So you need not to split this overcast again, because you can see all the things are yeses. But whenever it comes to sunny and rain, you have yes as well as no's together. Yes. Now that's the reason you have to split sunny node and rainy node further. So how can you split this? Now we have taken outlook. So already outlook has got splitted. Now we have either humidity or wind. Either humidity or wind. So in the first subset, I would like to split with humidity. Again in humidity, how many we have? High as well as low. So with humidity, all the high observations will come together and all the normal, it's not low, all the normal observations will come together. In the same way, after this is done, then here as humidity is already done, I will be splitting with wind. Now wind has weak as well as strong. Weak as well as strong. So weak data gets split further and strong data gets split further. So did you understand this, everyone? Did you understand this, guys? Yes. Fine. So now my decision tree is been formed. Now whatever the data you give based on these decisions, it will say whether the person will play or not. So here you have yes, this means yes, this means no. Green means yes, red means no. All right. So my decision tree is being created. That's very good. So we have given a data for the prediction, right? So the outlook is rainy and the wind is weak. So if the wind is weak, then the person will play the game. All right. So if suppose I give sunny, high rain and weak wind. I mean, yeah, sunny, high humidity and weak wind. Now tell me whether the person will play or not. The overcast is sunny, the humidity is high, wind is weak. So now the decision tree will take in this way. So overcast is sunny. The outlook is sunny. I'm sorry. Outlook is sunny. Then the humidity is high. So that means the person will not play. So this is my decision tree. Now, how can you say that I have to split the data set on Outlook? After that, why am I using humidity here? Why am I using wind here? How is it possible? That is purely based on entropy and information gain. So entropy is nothing but disorderedness of data or impurity of data. So first suppose all the data, all the things are merged together, then the entropy of it will be very high. The entropy of it will be very high. So if suppose the entropy is high, then the disorderedness of data is high. Okay. So for that, to remove that disorderedness and convert the data into an ordered format, we should make use of information gain. We should make use of information gain. So information gain is nothing but called as the reduction in the entropy. Okay. So again, I'm telling you guys, which attribute to split on, whether it is outlook or whether it is wind or whether it is something else. So that is purely based on entropy as well as information gain. Entropy is nothing but called as disorderedness of the data. What is understood, guys? What do you understand by entropy? Yes. So first suppose in a box, if you have books, toys, pencils, all the things together, then the box looks clumsy, right? Because there is no proper distinguish between items. All the things are included in that box itself. So that means the box is having so much of clumsiness or so much of disorderedness of the items. Now what I do, I split the data, split that box. How can I split? I put all the toys together, I put all the books together, I put all the pencils and all the stationery together. So whenever I split it, then each and every separate split will have low entropy. That means the data is ordered. So how can you split the data into an ordered format? With the help of information gain. So now did you understand what is entropy? For sure. Did you understand, guys? Yes, just relate it with what I say. A box containing all the things together. That box has high entropy because it is having some sort of clumsiness. Now what I do, I get another four separate boxes, and each separate box I put all the homogeneous data, all the homogeneous things together. That means all the stationary stuff together, all the toys together, all the books together. So when compared to the box with all the things together and the individual boxes, the entropy of the box with all the things together will be high because that is having clumsiness. But other boxes, it doesn't have any clumsiness of the data. All the things are homogeneous. So to that particular individual box, entropy will be low. So here a human being will be picking all the items and will be replacing them into separate boxes. But in the data set or so, how is it possible? There should be some mathematical creation, right? So that is what about our information gain. So first let's look into this entropy. So entropy is nothing but, guys, someone is drawing some arrow marks on the screen. Please don't do that. Okay, so here probability of negatives plus log 2 of probability of positive minus probability of negative examples and the probability of the positive example. So P plus is nothing but the proportion of positive examples in S. P is proportion of negative examples in the S. Here S is nothing but the total data set. So let's calculate the entropy, the disorderedness of the data set. So higher the entropy, higher will be the disorderedness. Lower the entropy, lower will be the disorderedness, right? So now let's calculate the entropy of data that I have. So now, P positive. Probability of yes is nothing but we have 9 yeses. Guys, please turn your mics off. Probability of so probability of yeses. So in the data set, everyone knows that there are 9 yeses and out of 14 observations. Did you remember this, guys? So if you go back to the so here I have 9 yeses and 5 no's. So the probability of yes will be 9 by 14. I hope everyone are very much familiar with probability, right? Yes? I hope everyone is familiar with probability. Yes. So probability of something will be the number of observations divided by the number of observations of particular data divided by total number of observations. Yes or no? So in the same way, probability of yes will be 9 by 14 and probability of no will be 5 by 14. So that's what we have put that in the formula. Now I have calculated the entropy. Now I got something like this. So did you understand this mathematical equation? The entropy formula is probability of yes log 2 probability of yes minus probability of no to log 2 probability of no. So did you understand this formula? Yes? Cool. Now, whenever you substitute all these things, you get 0.409 plus 0.530. So that becomes 0.939. So the disorderedness of data is high, because here we have yeses and nos together, right? So now you have to separate the data set into pure sets. That means homogeneous sets. Now, in order to separate the data into homogeneous sets, first of all, you have to know which attribute is to be used for splitting the data set. Which attribute is used for splitting the data set? So how do you know that which is the attribute? That is purely based on the information gain. So information gain is nothing but the reduction of entropy. Reduction of so it's a measure of the reduction in the entropy or surprise by splitting a data set according to a given value of a random variable. A larger information gain suggests a lower entropy. So if suppose the information gain is high, then that means it has lower entropy. So lower entropy is nothing but that particular element does not have so much of disorderedness. So much of disorderedness. So how do you calculate the information gain? So the formula of information gain is nothing but entropy minus summation of subsets, entropy of subsets into observations in the subset divided by total number of observations in the data set. Observations in the subset divided by total number of observations in the data set. So now first we will calculate the information gain of wind. We will calculate the information gain of the wind. Okay. Now tell me from this, what are the observation of the winds? What could be the observation of the winds? Can you please tell me? Observation of winds. So I have 9 observations, right? So now coming to week. So how many observations are there for week? This is 1 observation, right? This is 1 observation. Yes or no? Good. Next week, where is this week? This is another observation. Next I have, these are all the another observations for week. Weak. Okay, now let's talk about strong. So how many observations are there for strong? So this is 1 observation. Strong. Strong. Strong and strong, right? So these are the observations for wind and strong. Okay. So now this is strong, this is weak, right? Yes. Now let's calculate the entropy of weak. Entropy of weak. So first of all, what are the positive values here? How many positive values are there for weak? Positive values for weak. Tell me what are all the positive values for weak? Positive values for weak are 6. So how many we have? 1, 2, 3, 4, 5 and 6. Good. Negative values for weak? Is equal to 2. So total number of observations for weak is equal to 8. Now let's calculate the probability. So what is the formula of probability? Minus PS log 2 PS minus P no log 2 P no. Right? Now, tell me the formula now. This is the PS. What is the probability of yes for weak? Probability of yes for weak. Probability. I'm talking about the probability. Probability is, these are the observations, ma. This is the probability, right? So probability will be minus 6 by 8 into log 2 6 by 8 minus, what is the probability of negative? 2 by 8 log 2 by 8, right? So this is the entropy of weak. Very good. Now in the same way, tell me the probability of strong now. Tell me the probability of strong now. Tell me the probability of strong. Or else tell me what are the positive values of strong. Negative values of strong. Negative values also 3. Okay. Fine. What is the entropy of strong now? Tell me now. What is the entropy of strong? 3 by 6 log 2. 3 by 6 minus 3 by 6 log 2. 3 by 6. Yes? This is correct, right? Now, let's see whether this formula and the other formula and the formula that we have written in the values of this and the values that we have written in the PPT are same or not. All right. So let's check. Now, so wind. So the total number of yeses are 9 yeses and 5 yeses. In week, I have 6 yeses and 2 nos. Yes, 6 yeses and 2 nose. Total number of observations are 8. In the same way for strong, 3 S's and 3 nose. So for strong, 3 S's and 3 nose. So I have calculated the entropy. The middle one is entropy. Now what is this 8 by 14 and 6 by 14? That is nothing but observations of week divided by total number of observations in the data set. So how many observations are there in the week? 6 plus 2 are 8, right? So that's the reason 8 divided by 14. 8 divided by 14. In the same way, for strong we have 6. So 6 divided by total number of observations in the data set is 6 by 14. Right? Now you just calculate the Ig, total entropy, minus sum of these two values. So we know the entropy value, right? 0.939 we got. Now entropy is 0.939. Entropy of weak is 0.463. Entropy of strong is 0.428. Now subtract everything. Now you get the value as 0.048. This is how you will be calculating the information gain of the wind. Understood till here, everyone? Understood till here? Yes? Good. Now you guys tell me for outlook. You guys tell me for outlook. So wind I got 0.048. You guys tell me for outlook. So again in outlook, how many observations we have? Again in outlook, how many observations we have? What are they? Sunny, rainy, overcast. Right? Yes. Now, how many sunnies are there? How many sunnies are there? How many observations of sunnies are there? 5. How many observations of sunny? There are 5 observations. Out of which positive are how many? Positive are how many for sunny? Two. Positive are 2 and negative are what? 3. Good. Now coming to rainy. How many rainies we have? 5. Out of which how many are positive? 3 are positive and negative 2. Negative 2. Now overcast. We have 4 observations. Out of which how many yeses? Positive is equal to 4. Negative is equal to 0. Now can we calculate the entropy for this? What is the entropy formula? Can someone tell me? Entropy of sunny. Just tell me the formula. No need of calculation. Formula you tell me. Yeah, formula in the sense with the substitutions, guys. With the substitutions. Yes, that's good. So that means minus 2 divided by 5 log 2, 2 divided by 5 minus 3 divided by 5 log 3 divided by 5. Yes? For rainy also the same thing. For overcast also the same thing. But here you'll get 0 by 0, something like that. Yes? So that's what is showcased even in the PPT. Now for Outlook. So what are there? So 2 by 5, 4 by 4, 3 by 5, something. So here this is total number of observations in Sunny divided by total number of observations in the data set. Now you get the value 0.90, something like this. Now information gain is nothing but again information gain minus all the values of all the entropies of subsets. So you get 0.247. So higher the information gain, lower will be the disorderedness. That means, so whichever the attribute is having high information gain, that is to be considered as the first term to split. First term to split. So that's the reason first we have used Outlook to divide the data set. Outlook to divide the data set. So from here also you can see in the Outlook itself you have one pure set. So that means the disorderedness is slight less when compared to humidity and wind. So now did you understand the decision tree? Now did you understand the decision tree? Yes? Everyone? Cool. Now, what happens is, in the same way, we have random forest. Random forest. So random forest is nothing but the data set is divided into 3 data sets. The data set is divided into 3 data sets. For each data set, the same amount of decision tree is calculated. The same amount of decision tree is calculated. For suppose, let's take the same data set. Let's take the same data set. So if it is a random forest, now what we are doing? For all the observations, we are creating a decision tree, right? Now if it is a random forest, then what happens is the data set is splitted into different data sets depend on the count I give. For suppose I have taken as 3 as a count, 3 data sets as a count. So randomly it will pick first 6 rows for the first data set, next 6 rows for the next data set, and some other 6 rows for the third data set. Now I have 3 data sets. So for each data set, decision tree is applied and 3 trees are formed. 3 decision trees are applied and 3 trees are formed like this. So here we have only one tree, right? Now if it is a random forest like this, you will have 3 trees. Now if suppose you give the data for, you give a data like this, here only one tree is been answering the question. But now this particular data is being given to the 3 decision trees. So out of which, if it is a classification problem, the majority is considered. The majority is considered. But if it is a regression problem, mean of 3 decision tree is considered. If it is a classification, majority of the answers is considered. But for the regression, mean is considered. For suppose, this gave, he will play. This gave, he will not play. This decision tree gave, he will play. Now what would be the answer? That is a classification problem. Now what would be the answer? because here the majority is yes. So that's the reason he will play. For suppose if it is a regression problem like house price prediction or so. So this decision tree gave 80,000. This decision tree gave 85,000. This decision tree gave 90,000. So at that time, 80,000 plus 85,000 plus 90,000 divided by 3. That becomes the answer for the random forest. So now did you understand the classification and regression of decision tree? Did you understand this? Everyone? Did you understand? Fine. Now, we have applied this for classification, decision tree. But what if it is a regression? Let's look into it. So just give me 2 minutes. I'll just showcase you that, okay? So again, I'm showing you if it is a decision tree regression. Now, what I am saying is, in the x-axis, I have, let's suppose this is the bank balance. All right. On this axis, I have something like credit card score. Now I want to split the data randomly. All right. So first what I do, I'll split the data at 50,000. Okay. Now from this is the first variable which is in x1. So I am taking the first split in the x-axis. Now the second time I'm taking the split in the second axis at 20. Let's suppose. Okay, I want to take some sort of conditions. So yesterday I took conditions like greater than 50,000, greater than 80,000, greater than 600, greater than 700 in the same way. So first split on x-axis and second split on y-axis. Fine, 2 splits are done. Again, I want to split it here at 25. The fourth split is at 100. And the other split is it like this. Fine. Now my data set got splitted in this way. Let's create a decision tree. Okay. So first one is x1 greater than 50. So the first split I took it as x1 greater than 50 only, right? Good. Now after that what I did, if it is yes, then I split it as x1 greater than 100. If it is no, I am taking it as x2 less than 20. If it is yes, it comes to the first split. If it is no, it comes to the second split. Now, if it is yes, again, the third split is considered. If it is no, again, the fourth split is considered. Now, what I want to do is, I will give the x1 as 100 and x2 as 40. x1 as 100 and x2 as 40. Now tell me where it comes. x1 as 100, x2 as 40. That means x1 is like bank balance is 100,000, credit card score is 40. Now based on this decision tree, tell me where is the split comes. Where does the split comes? x1 is greater, x1 is 100, x2 is 40. So first it will check the condition. Is the x1 greater than 100? Yes. So it comes to the second decision. Is x1 greater than 100? No. It's equal to 100. So it becomes no. That means x2 less than 24. x2 less than 24. So here I have missed something. So if suppose x2 is less than 24. x2 is less than 24. So where the data comes, x2 is less than 24. Where does the data comes, guys? Split 2 or split 4? This comes under split 4, less than 25. Here I'm splitting the split 4. I'm splitting the data over here. So now the answer is, for regression, mean of data situated in the fourth split. Mean of data situated in the fourth split. So if it is a regression, then you will be considering the splitting of numbers. If it is a classification, then that depends on the information gain and entropy. Did you understand this, guys? Did you understand this or not? So again, I'll give you an example. Now x1 is 25, x2 is 15. x1 is 25, x2 is 15. Now in which split it comes? x1 is 25, x2 is 15. x1 is 25, x2 is 15. Is it the first split or second split? So x1 is 25. Is x1 greater than 25? No. So this comes here. Is x2 less than 20? Yes. So the data is under split 1. So where is the split 1 here? Over here. So mean of all the data will be the regression answer. So did you understand this, guys, now? If you understand, shall we move on to the practical implementation? Understood? So how can you say that these splits are perfect? How can you say that these splits are perfect? This is again comes under mean square error. So first what happens is the randomly some splits are drawn. Okay. So after getting the output, it will check the predicted value as well as the output value. So in linear regression, we did the same thing, right? So first suppose here I have given x1 as 25 and x2 as 22, right? All right. So this is shown as split 1. Okay. So now in the split 1, the answer I got is 20,000. But actual value is 50,000. So that means there is some sort of variation. Again, what happens? The splits will be changed. Again, the error will be calculated till the error is minimum. Did you understand this or shall I explain it in a brief way? Did you understand this or shall I explain it in a brief way? I mean in a detailed way. This mean square error and all. Are you able to relate it or should I explain it in a detailed way, guys? So guys, first suppose here I have value as 25, 100, x1 as 100, x2 as 25. Okay. The output is, let's suppose it is 90. Let's suppose it is 90. Okay. Now we have so many columns like this. $75, $30, $86. 25, 40, 60, something like that. Just imagine, guys. Just imagine. Okay. Now, what happened is, so my splits are being happened. I have splitted my data. Let's suppose these are my points. Okay. Let's suppose these are all the points. Fine. I have splitted my data. Okay. Like this, like this, like this, and like this. Okay. Fine. So after splitting, what it gives is it will send the values as 125. Okay. So whenever it gets 125 based on the decision tree, okay, I got the output as 52. Based on the decision tree, I got the output as 52. So now this output and this output similar. This output and this output is similar. No. So what happens? Mean square error is taken place. So 90 minus 52 divided by n whole square. So I told you the formula of mean square error, right? This is the error. Okay. Now what happens? The splits changes. Now here what happens second time? For the second time what happens? Instead of the split over here, the split starts at x1. The split starts at x1 second time. Now this will be x2, this will be x3. Again the decision tree is formed. Again you send the values as 125. After passing to the decision tree, I got it as 92. I got it as 92. Now the mean square error of 90 and 92 are calculated. So this becomes error. So now out of these two errors, which is the error which is very small? Which is the error which is very small? First splits or second splits? First splits or second splits, guys? Second split. So this is considered as the perfect split. All right. All right, guys. Now, did you understand? Did you understand now? Yes? Good. So, in regression, mean square error is considered to split the data. In classification, what is it considered, guys? In classification, what is it considered? No. For splitting. For splitting, what is it considered? In regression, mean square error is considered for splitting. For classification, entropy and information gain. All right.